Hello, welcome to this channel. Today I'm going to be showing you this math problem that I found. It's from a movie. I did watch the movie. I didn't enjoy it, but I did like the question because you can actually write Java solution to it. So let's just get in. So basically, to summarize this, there are 20 cards, and then you have a move which flips a card that has to be face down, then the card to the right of it, no matter if the card is face up or face down. And you have to prove that as long as you keep making these moves, you're going to eventually run out of options to make the moves, basically. So what the main character did was that he represented face down cards as 1 and face up cards as 0. And then what he said was that you're going to have a list of 1s, obviously. And then every move, you're going to have 1 as the leftmost value. Because the move would contain 2 values, and then 1 has to be the one at the left. So you could either have 1, 1, which is equal to 3 in binary, and then 1, 1 goes into 0, 0 when you make the move, for obvious reasons. And then 0, 0 is equal to 0, obviously, in binary. And then you're going to have 1, 0, 1, 0, which is equal to 2 in binary. And then 1, 0 is equal to, 1, 0 goes into 0, 1, which then is equal to 1. And what he noticed was that the value goes down in binary for every move, which means that all the values in the 20 card list will eventually become face up, which means you can no longer make any moves. Therefore, you've proven the question right, basically. So for us to actually make this program a solution, we have to make sure it's arbitrary and not just a sequential way of just making a move and then going to the next. So we're going to have to use a random number generator to choose where we want to start, basically. And then once we do that, we're going to have to make sure that the value we're checking at leftmost is 1 and it's not at the end, pretty much. So without further ado, let's write what we're going to need to do. We're going to need to get an array of integers, and all 1s, so they must all be 1. And then we're going to choose a random value in array. So we're choosing a random value in the array, pretty easy to do. And then assert that it is 1, right? So we just have to make sure it's 1 because we're getting a number to the right, basically. And then we're going to have to do conversion and print values. So we do the conversion, so if it's 1, 1, we flip to 0, 0, and if it's 1, 0, we flip to 0, 1, and then we print out what we got. And then we keep repeating this until all the values are 0. And we're going to need a few methods. So we're going to need actual main method, which is the cards, and then int array, so an array. And then we're also going to need a convert binary to decimal int, because we want to show actually that the value is going down each time to prove this solution. And then we're going to need, what else are we going to need? We're going to need to check values to make sure that all the values are 0 still, and we can successfully terminate the program, basically. So without further ado, let's get writing. Right, so I've written our imports, so this is all we're going to need for this. So we're going to have our main method, obviously, so we have that there. Then let's have like an integer array of like a string or an array of 1s, pretty much. So 1, 1, 1, 1, 1, 1, 1. Alright, so we have that. And then we're going to need another method, private static void cards. It's going to take in int. It's going to take in a bunch of cards, pretty much. Yeah. And then we also need, like we said, a check values. So private static boolean this time will be check values. Okay. And then finally we're going to need a private static int, so binary to decimal. So let's work through all of these methods easiest first. So check value is going to be pretty easy to do. All we do is just make a for each loop, and then if I does not equal 0, return false. This is so finicky, but if I does not equal 0, return false, and if it does, then just return true. That's quite annoying, but yeah, that should be it pretty much. I want to inline this, but to make it look a bit nicer. Okay, so that's pretty much the whole method. And yeah, so to move on to this, what we're gonna do, I think we should map it to a string array instead. So str array equals arrays.string. Strings are actually really useful. I can talk about them in another video, but I'm just gonna use them. So I'm gonna map to object, and then string value of. So we get the value of the string, and then we map it to this array, and then we're just gonna put to array as a new string. Right, that should be good. And now we just convert into a string builder from there. So string builder str builder equal new string builder. Right, and then for string str array. Actually, let's leave these curly braces, we don't need them. So str.append s. Right, so that's good over there. And now all we have to do is just return integer.parseInt, then string builder.toString, and then set the radix to 2, base 2 binary, like that. And then that's those done. What do we do here? Okay, that's weird. I think I'll just ignore that. Yeah, that's fine, that's good. Yeah, a little bit weird, but anyways, what we need to do first is we're gonna print out everything. So print out arrays.toString cards, and then in decimal is gonna be binaryToDecimal and then cards. Now once we have that, we're gonna say if cards.length 2, then if it does not equal 0, then it's out. So it must be even, and then return. So just go to the end, don't run any of the code pretty much. And then now, to save memory, we're gonna write the random outside of the loop. So new random. Then we're gonna make our loop. So while checkValues cards, then int I equals random.nextInt cards.length -1, because we don't want the end value. We never want the end value, because end value can never be the leftmost value. So we get int val equals cards I. Then if val does not equal 1, continue. And then now we're gonna execute what's it called? Execute conversion. So cards I is gonna be equal to 0 all the time. Equal 0. And then cards, this is a really cool Java thing. So cards I plus 1 is equal to cards I plus 1 equal to 0. Well, that's a completely wrong curly brace. Not even a curly brace, just a wrong brace in general. So there's gonna be a boolean expression there, and then with that boolean we're gonna put a question mark. I think it's a question. Yeah, it's a question mark. We're gonna have 1 or 0. So what that does, it essentially tells us that if that does equal 0, we're gonna switch it to a 1. If it equals to 0, we're gonna switch it. So if it equals to 0, we're gonna switch it to a 1. And if it doesn't, we switch to a 0. Pretty much. Hope you understood that. So once we do that, we can print out. Print it out like so, and then just keep looping out, I guess. So now we can just run cards I, and then this looks like it's all good to run, and yeah, let's just run it. Okay, so of course that's a bit weird, unexpected. And yeah, what we notice now is that the length of the cards are not even, obviously, so we have to change to an even value. So let's just try 8. So 1, 2, 3, 4, 5, 6, 7, 8. So let's try 8 numbers. Hopefully that works like it should. Yep, and as we see, what we first notice is that when it goes through each one, it actually goes to 0. So it flips it to 0, and then it flips to random 1, 0. Then it flips to another random 1, 1, 0, flips to 0 and 1. Then it just keeps going down until it gets to 0, 0. And then what we notice here is that the numbers keep going down in binary. Keep going down. I could graph this, but I'd rather not. And as you see, if you keep running, it is truly random, so the values are changing. And it stays about the same with the length of the array. So yeah, as we see, it always starts with a bunch of 1s and ends with a bunch of 0s. The most efficient way to do this would be just go through each one by one. I think that's why, nope, we didn't do that here. But yeah, I think we do this recursively, but I think we'll do that a bit later. Maybe today if I feel like it, but that's just what we're gonna do, so yep. So I looked for a bit and I don't think there's a decent recursive solution. This is what happened when I tried one. It did not go to plan. Yep, that's a lot of damage. So we're just gonna keep this solution. I'll put the code in the description. I'll put this in the description as well. But if you like these types of videos, please keep subscribing, keep viewing them, keep liking, because then I'll make more. And yep, have a good day. See you on the flip side, I guess.